Hi, in today's video I would like to introduce you a very nice problem. Here is a nice inequality. Our goal, we are going to prove this inequality. We have pi squared over 6 minus 1 is strictly inferior than the sum of natural log of 1 plus 1 over n. Quantity square is strictly inferior than pi squared over 6, okay? In fact, this problem came out on the form of a regular integral. Then I make some renovation and make it more harder. So now we are going to see this sum how looks like, okay? Go ahead, pause this video if you would like to give a try to this problem. We will come back to see the full solution, okay? Let's get started now. Let's set t as a real positive number. We have number 1 is strictly inferior than t and is strictly inferior than 1 plus 1 over n. So this one equivalent, I'm going to make the reciprocal of t. I will have 1 over 1 plus 1 over n. This inequality will be flipped. I'm going to flip this inequality, so I will have the reciprocal of t. It will become 1 over t is strictly inferior than 1, okay? So what I'm going to do now, I'm going to apply the regular integral on both sides, okay? This one implies the integral of 1 over 1 plus 1 over n dt from 1 to 1 plus 1 over n is strictly inferior than integral of from 1 to 1 plus 1 over n of dt over t is strictly inferior than integral of dt from 1 to 1 plus 1 over n, okay? So this integral, the term on the, I'm going to take 1 over 1 plus 1 over n outside of this integral because it's considered as a constant. So this one implies 1 over 1 plus 1 over n, the integral of dt, the bound from 1 to 1 plus 1 over n, is strictly inferior than integral the dt over t. It becomes natural log of t, the bound from 1 to 1 plus 1 over n is strictly inferior than integral of the right hand side of this inequality is t, the bound from 1 to 1 plus 1 over n, okay? I'm going to simplify this one more. I will have 1 over n is multiplied by 1. I will have n plus 1 over n. The integral of this one, I will have t, the bound from 1 to 1 plus 1 over n. It's strictly inferior. This integral, I will have natural log of 1 plus 1 over n minus natural log of 1, which is 0. It's strictly inferior than this one. This one, I will have 1 plus 1 over n minus 1 by replacing t with 1 plus 1 over n minus the term minus number 1, okay? So number 1 will be cancelled out. So we'll have this one equal 1 over n. I'm going to simplify this one. This one, reciprocal of this one become n over n plus 1 is multiplied by this one. I will have 1 plus 1 over n by replacing t with its value minus 1, strictly inferior than natural log of 1 plus 1 over n. Natural log of 1 equal to 0, strictly inferior than 1 over n, okay? This one equivalent, I'm going to simplify number 1 as well as n, okay? So I will have 1 over n plus 1 is strictly inferior than natural log of 1 plus 1 over n. It's strictly inferior than 1 over n, okay? So if you take a look at this inequality, it's going to be similar to the original one which we want to prove, okay? So what I'm going to do now, just the thing that I'm going to do now, I'm just square both sides, okay, of this one. So by squaring this one, I raise number 2 as a power. Okay, in the same time I'm going to apply the sum on both sides. So we have the sum of 1 over n plus 1 quantity square as n goes from 1 to plus infinity is strictly inferior than the sum of natural log of 1 plus 1 over n quantity square as n goes from 1 to plus infinity is strictly inferior than the sum of 1 over n square as n goes from 1 to plus infinity. If you take a look at this sum, it's more known sum which is convergent. Okay, so what I'm going to do now, I'm going to calculate the sum of 1 over n plus 1 quantity square as n goes from 1 to plus infinity. I'm going to calculate this sum as n goes from 1 to plus infinity of 1 over n plus 1 quantity square equal to 1 over 2 quantity square plus 1 over 3 quantity square, and all the way down until you get infinity, because we have convergent sum. This sum is a convergent sum because this sum is a convergent. As we know, this sum is more known. Okay, equal to pi square over 6 is a famous sum. Since this one is strictly inferior than this sum, that means this one is automatically going to be converged as well. Okay, so I'm going to distribute this one. What I'm going to do now, I'm going to add number 1 on both sides. Okay, plus. So now this sum equal to the sum of 1 over n quantity square as n goes from 1 to plus infinity. Okay, in the same time this sum equal to pi over 6 equal to pi square over 6. This sum was proven before. If you would like to take a look how to prove this one, just go back to my previous videos where you can see all the details. Okay, so now this sum 1 over n plus 1 quantity square as a reciprocal of n plus 1 over quantity square as n goes from 1 to plus infinity equal to pi over 6 minus number 1. Okay, so I'm going to replace this one with pi square over 6 minus 1 is strictly inferior than this sum of natural log of 1 plus 1 over n quantity square as n goes from 1 to plus infinity is strictly inferior than this sum of 1 over n square as n goes from 1 to plus infinity equal to pi square over 6. Okay, as we just discussed now. So now this is the proof of this inequality. Now we have done with this problem. Just consider the subscribe. If you have any question or suggest, just put it in the comment section below. Thank you for watching. I will see you in next video. Bye.